Great. The YouTube live stream is up. I will drop the link in the chat if anybody wants to watch there. People can ask questions on the YouTube live stream chat as well, so I will monitor both lives. So we are live, and Grace, Lucas, and Peter, if you'd like to kick it off, go right ahead.
Great. Let me go ahead and share my screen. Thanks everyone for joining. Very excited to have you here. Hopefully you guys know you're in the right place. And we're today talking about Ethereum within the Hyperledger community. This is part 2 of a series. This session will be a little more technical than the last session we had. If you haven't already seen our first session, we highly recommend you check it out. But not a prerequisite, you know, this will just be covering slightly different things. I will go ahead and introduce myself. I'm Grace Hartley. I work for Consensus on the Consensus Quorum team as a senior business operations manager. A lot of my work is in internal ops and strategic partnerships. I also sit on Hyperledger's technical steering committee and work closely on the Hyperledger Besu team. Lucas, you want to go next?
Sure. Hi, everyone. My name is Lucas. I've been working for Consensus for a bit over 3 years now. I work in the protocol team, and we've been doing a lot of work around Besu and some other projects as well. Yeah, glad to be here.
Hi,
And Peter.
Yeah. I'm Peter Shomajvari. I work for Accenture as a technology architect, and I'm full-time one of the maintainers of Hyperledger Cactus, which is one of the projects we're going to demo today.
Perfect. So moving us along quickly here as the agenda. So we're going to cover a few things, but I like to say this is not your typical webinar. This is not us talking at you for 45 minutes or an hour. We want this to be highly collaborative. We want you to ask questions, jump in. That's why we have everyone able to mute and unmute themselves, use the chat, ask questions, all that. So essentially we've prepared some information and some slides, but if there are no questions, this would be over very, very quickly. So don't be shy is the point. This is, you know, for your learning, your education, and we're here to be a resource to you. So anyway, but what we will cover, kind of looking at the bullets we have on the slide. So we will do a quick recap of Ethereum and how it fits into Hyperledger, just in case you missed the last session. We'll move through it pretty quickly, but just to set some context for this. Then we will have demos of both Besu and Cactus, and Lucas and Peter are going to help me out a lot with those. And by that, I mean they're going to do them for me. We will also be having lots of questions, and then we also want to make it easy for you all to know how to get involved. So we'll wrap up with some information on where you get started and make it as easy as possible for you. And with that, as I mentioned, it's going to be highly collaborative. You'll be seeing a lot of polls popping up, hopefully, if David's ready for me. And this will help us kind of frame the conversations and hopefully get us kind of, you know, knowing who our audience is and what your familiarity was with the projects and Ethereum. So the first poll that we have, and David, if you're ready to post it, that'd be great, is how would you rate your understanding of Ethereum? Just getting started. I know some about Ethereum. I'm an expert and work in Ethereum every day. Looks like we've had it. We'll give everyone another second. It'd be really awesome if we start with 100% participation on this first one.
Seems like most people have voted now. I see 13 out of the people who are here. Give maybe a few more seconds.
Yeah.
Okay.
I don't know if the 13 out of 15 is, do we count in that list? Yeah.
There we go. All right, well, we get 14 now.
Pretty good. Okay. So it looks like the majority are, the winner is I know some about Ethereum. So it's good to know. And then just getting started and excited to learn more is the second, is about half the group. And then one person is an expert. So this is great. This is why you're here. We're here to help you become experts, maybe slowly. And yeah, just feel free to jump in with any questions you have. So maybe just taking a moment, what is Ethereum? Ethereum is the open source blockchain. It launched in 2015. It has one of the largest developer communities in the world for blockchains. I think it's at over 250,000. It's often considered the most programmable blockchain for creating decentralized applications and smart contracts. You can use Ethereum, so it's a public blockchain, but then there's also flavors that we'll talk about with Besu and others, where it's also permission blockchain. So if you're familiar with permission blockchains or permission DLTs, you can also use it for that. Lucas, Peter, anything else to add to kind of set the scene?
No, I think you got to the point what Ethereum is. Yeah, it's the way that I like to think about it is this distributed computer over the network. So maybe it's more like a protocol way of thinking about it, but yeah, it's kind of this computer that is available to everyone, and we can all use in some sense. But yeah, I think you did a great job talking about it.
Yeah, I have nothing more to add. It was great.
Cool. Okay. So again, we're moving through this quickly just because we want to get to the demos and the fun stuff. But setting the scene here, if you were at the last session, you all are obviously familiar with Hyperledger and the Hyperledger greenhouse. Sometimes we get the question, what's the difference between Hyperledger and Ethereum? And in fact, there are Ethereum projects in Hyperledger, including Besu, Burrow, and then Avalon and Cactus also interact with Ethereum. Besu is the enterprise Ethereum client that's written in Java, which we'll talk about a lot with Lucas. Burrow is the permissionable smart contract machine, or an EVM, Ethereum virtual machine. Then there's Avalon, and then there's Cactus. Peter, do you want to give a quick intro to Cactus?
Yeah, just a 30-second version of it, because we really want to move fast. Is that Cactus is a framework for integrating or interoperating different distributed ledgers. So it's not its own ledger. It's there to help you create applications that have to deal with multiple ledgers at the same time. It's sort of an SDK of SDKs.
Okay, so the SDK of SDKs. I think, so when you're looking at kind of Hyperledger and you're thinking about all of, it is kind of a greenhouse for enterprise blockchain DLTs, libraries, tools, labs, as you can see in kind of this view. And it's pretty cool that, it's not necessarily Hyperledger versus Ethereum. It's actually kind of, it all fits together pretty well, and you have kind of different options. So, I like to say that if you're thinking about getting started with blockchain or distributed ledgers, go to Hyperledger and you'll be able to see kind of, there are a bunch of different flavors. You can figure out what works for you and get a good sampling of what's out there by just coming to this group. Any questions? Again, please feel free to jump in. This is not a talk
Hello?
at you session. Hey, yeah.
Can you hear me?
Yep, I can hear you, Greg.
Oh, hi. How are you?
Good.
So I'm good, thank you. I think the first chart said quorum, and now I see Besu. How do they relate to each other?
I'm not sure what the first, I was like, do I have a slide of, I don't call out quorum explicitly here, but so I guess taking a step back, so there are a few different clients that run on the Ethereum network. One is Hyperledger Besu, one is GoQuorum. GoQuorum is owned by Consensus and my team as well. But there are kind of a few key differences between the two clients. So Hyperledger Besu is written in Java and can run on the public chain as well as permission networks. GoQuorum is written in Go and can only be run in permission network settings, and it's a fork of Geth. So they're kind of, and GoQuorum is not a part of the Hyperledger greenhouse. It's owned by Consensus, as I said, but Hyperledger Besu is a part of the Hyperledger greenhouse. That's a good start? Was that helpful?
If I can ask a follow-up question,
Absolutely.
unless somebody else wants to ask.
Go
So
for it.
my understanding is the quorum was somehow funded or owned or developed by JP Morgan at some point,
Mhm.
and that project ended. And now it's Consensus, I believe, that
Yep.
owns the rights.
Yeah, exactly. So Go Quorum was originally built by JP Morgan, and Consensus acquired it back in August of 2020. Currently, the Consensus team builds both Hyperledger Besu and Go Quorum, and we're a team that work on both of them. But I guess to be clear, there's not they're both being worked on by the Consensus team. So I think your question was, the Go Quorum project, has it stopped? And the answer is actually no. Both of the which are working on. And what's kind of cool is when you're thinking about enterprise Ethereum and Ethereum projects generally, and enterprise DLT, it's pretty cool to kind of have different projects being worked on together. Yeah.
Thank
Does
you.
that help?
Yep.
What other questions are out there? Great. Okay. So we have another poll for you all to participate in. So we'd love to hear, what problems are you trying to solve with using a DLT? Data traceability, security, collaboration, lower cost, maybe transaction fees, or do you want to have productivity increases to your business? Or maybe there's something else. If so, drop it in the chat. We'd love to get your feedback. Looks like we've almost had everyone's participation. Looks like collaboration is the leader at this point, which is interesting. Lucas, what do you think of that?
Yeah, I think this is probably one of the most common use cases, and that's something that we hear a lot from different people that want to use it. And that's probably one of the best scenarios where a consortium or private chain will, fit perfectly, because a lot of the time, most people think about Ethereum and this open network that anyone can join. But I think one concept that not everyone understands is that, like, mainnet is only called mainnet because it's open and everyone wants to join. But there's nothing preventing people from starting their own nodes and building a network for themselves. It's almost like, I don't know, if you think about one of those wiki internal websites that only the company has access to or something. You can build those kind of networks to fit your needs, so you don't have to use the open mainnet network for that. So when it comes to collaboration, a group of entities might decide to have a shared ledger to collaborate and share data in a specific format. Again, touching on traceability and security and everything. So you have this trace of everything that's happening, and not a single entity can just go back and erase everything. So I think those things kind of walk together. And it's cool because one of the things I'm going to show in the demo is actually how you can build a permission network and send private transactions and things between entities. So hopefully it can give everyone a glimpse of what a consortium network is going to look like.
No, teeing us up beautifully. Yeah. Peter, were you going to chime in?
Yes. Yeah, I also like this very much, that this is the result that we've gotten, because on top of Cactus just trying to help abstract away the mechanics of interacting with different ledgers, we also put a big focus on creating and managing consortiums, and in a way that is baked into the plugin architecture that we have itself. So there's a lot of flexibility in there on how you can or will be able to create and manage a consortium depending on what is the actual legal or trust framework that you want to apply there.
Yeah, and I will say, what's really cool is what Lucas and Peter are going to show. The technology works, but sometimes to create a consortium, but actually kind of sometimes the hardest part is, the people aspect and the getting all these competitors to work together, and it's actually not the technology that's the biggest blocking point. So, or at least we're going to try to show you how it can be easy. Mark, I'd love to hear about the unifying disparate architectures comment, and if you can provide more context, that's really great feedback.
Sure. I basically been working on several projects to where you had these larger enterprises that really their IT landscape is just a horror show of siloed, disparate disparate platforms that are either incompatible or at least non-communicative with each other, and a lot of gatekeeping tends to happen. Before I got into blockchain, I had a background as a risk manager that basically needed to have a single pane of glass dashboard that they could pull, through APIs and get data from the various different enterprise departments and stuff, so they could, have it all in one place. And that was really difficult to do. And, looking at blockchain, I saw that there was a way that this could actually be a unifying solution to it. So that's really how we got into it. And you have a lot of the projects that I've been working on are really, of that flavor. So
yeah. No, that's great context. And you're right. Yeah, no, like all the legacy systems being, weren't built, thinking of how they all work together. It was, they were built for one specific need. And now how are they all going to talk to each other and what makes sense? And how are we cross communicating? That makes a lot of sense. No, that's great. You should have put that one on the poll.
Yeah. Well, and another headwind that I think all of us fly into and stuff is, as we get closer to an actual implementation, you start to contemplate how does the blockchain solution fit into the IT architecture, because I think by now, those of us that have done some laps around the track trying to create blockchain solutions as databases on steroids, is great in theory, but in practice, it's a completely different animal.
For sure. Yeah, no, and that's something like at least with the Besu team, like we're all constantly thinking about deployment. How are we making it easier to use? What is, a network administration, and not just, if you don't, how do you fit it with the other enterprise applications and all that? So that's definitely constantly a discussion. So that resonates, at least with me.
So yeah, and so you're going to have a lot of people, a lot of enterprises that have made significant investments in their ERP systems, and they are not going to just rip and replace with a blockchain solution onto that. So we start looking at more creativity as far as how it actually fits whether it's going to be an event bus or a proof of consistency between state machines, that sort of thing.
Yeah, no, for sure. I mean, as much as, maybe I'd really like them to blow up the ERP machine, but it's unrealistic knowing them.
Yeah. And I think that's an interesting scenario that we see with some companies, is that it's almost like there's a journey between understanding, what you could use blockchain for, and actually, when you start using it and then you find that it fits for specific purposes and some other purposes, not directly one-to-one mapping. So, the thing that Mark was talking about where, they have like a regular relational database or something, and suddenly, we can move everything to smart contracts and put all this data on the chain and everything, without realizing that that's not necessarily the best use of the two. So I think this is part of the journey, and part of the learning is actually also understanding where the blockchain would fit and solve problems, and not just create more problems, and the other way around as well. So I think that's just an interesting thing to, and I think it just takes like maybe time, or just more research for whoever wants to use the technology, understand and make sure that it's not just don't look at it just as another database. It's more than a database. You can do so many more things. But yeah, I just thought that was something interesting to highlight, that this journey that we see companies going through, and not just, I mean, the technology is new, so I think everyone's evolving and learning together. But yeah, that's interesting.
Well, and one thing that I see is, we have to constantly, or at least drive home, demonstrate that blockchain can outperform the current delivery environment and do so cost effectively. I think we can easily do not easily, but I think we can definitely do the outperforming part. It's the cost effective part that is tricky.
Oh yeah, for sure. I know that's interesting, but yeah, it's interesting though. In the poll, nobody said what problems are you trying to solve: lower costs and productivity increase. No one said, and it kind of. But you're right, or it kind of goes hand in hand, at least when you're building the business case. We'll keep going. So I think we kind of already covered at least the intro section to these. So I'm actually going to jump ahead to our next poll, if that's all right. So what are you hoping to see in this demo? How to connect it to mainnet, how to send a private transaction in a permission environment, how to create a web application to interact with multiple ledgers, or something else. Would love to hear what you all are thinking.
Oh, nice.
Wow, Peter's going to be excited about these answers. I don't know if this is what I was expecting, actually, which is actually really great. I know. So the good news is that we're showing all of these things. Mark, we're probably not going to show a private transaction in a public network, but Lucas can probably talk about how Besu does solve for that. So the first two will be solved and demoed by Lucas, which is how to connect to mainnet Ethereum and how to send a private transaction in a permission network. He'll talk to the private transaction in a public network. And then Peter is going to be doing how to create a web application to interact with multiple ledgers with Cactus. So we did kind of tee you up for that. I apologize. But with that, Peter, I'll let you go ahead and kick off the demos. And for anyone who wants to follow along, we have the links here, but I'll leave the floor to you.
Thank you. Let me share my screen real quick. Yeah, the computer gets a little slow when I do this. Apologies. It's going to take a few seconds for it to catch up. But I can talk in the meantime. So there's one takeaway, or a few takeaways, that I want to highlight, which is number one, you can and you should try this at home. Here's the terminal command that I will show, and this runs on any computer with Docker that does not have an ARM CPU in it, which nowadays you actually have to say that because they started rolling out these laptops with that fruit logo that have ARM chips in them. So, but anyway, I'll run this command. Paste anyway, living on the edge. This will pull up a container with our supply chain app example, which is a web application, but also
I'm sorry. Can I ask a question?
Yeah, sure thing. Go ahead.
What is this localhost supposed to do here? I'm talking about somebody posted into the chat localhost link.
Oh, that's just one of the links to follow along. I just dropped in the chat from the slides.
Doesn't make any sense because it's my
machine. Yeah, no. Yeah, we need the rest of the command line. I'll copy and paste as well.
I think the idea is that if you're running the demo in your machine, you can use the link, but I think it's just the order that the link came before the command line.
Sorry.
Right. No problem. So the other point I want to make is that this is relatively low resource usage, so you should really be able to run it on your laptop, despite it being completely end-to-end of a simulation. It only uses about 2 gigs of RAM right now. And I will also show that I have this Docker container running now. And if I get into it, and then, oh, sorry, crash. Then I do Docker PS, then there's Docker containers running inside that container. So this is truly an end-to-end example that simulates the ledgers themselves as well. And I think by now it probably booted up, so I will get over to this, which is the local host that you can also use if you are trying this at home, which you should.
And so Peter, you're basically showing, or you're going to be showing how Besu and Go Quorum are connecting. That's
yes.
Yeah. Just
Yes.
take it a step back there. Yeah.
This is a run-of-the-mill web application that manages data. So it's very boring, and that's by design. And you can book bamboo harvests and bookshelves in it. Bookshelves are made out of bamboo in this case. And the data for bamboo harvest is stored on the Quorum ledger that's running inside that container right now. And the bookshelves are stored on a Besu ledger. And the bottom line is, oh, sorry, not this one, the other one. So first you have to create a bamboo harvest list, or a bamboo harvest record, sorry. It's just dummy data. When I submit it, this sends a REST API request to Cactus, which then sends a transaction to the ledger and saves the data there in a smart contract. And then the web app, this is where the integration or interoperation part comes in. Now the web app fetches the data from the Quorum ledger for the bamboo harvest, and you can actually select that and make an association between the data on the two ledgers by adding the primary key, which is how you would do it with an old traditional database. And then if you hit this, then it gets saved, then you have this record. So now you have these records, one referencing the other, and they are on different ledgers. But the point here is that the web application does not really make a big deal out of this. And all you have to do, apart from some extra boilerplate code, the way it looks like when you actually do these data insertions, is to call, the smart contract method insert record on the Besu and on the Quorum connectors. And this is how it looks. And the other thing is, you could ask, well, I could do this in 10 lines of code with Truffle and Web3 as well. But and to that, I will say that in the coming weeks, we are also adding into this example Fabric and Corda, which are also ledgers that we are supporting now. And then suddenly that equation looks much different, because you can really start to see there the value of having a framework where an API call to a transaction on the ledger can be issued like this, and it's almost verbatim copy pastable over in between ledgers if you want to add the new one, as long as there's a connector plugin for it. Just the last thing I wanted to show is the insert bamboo harvest endpoint. So if you compare this to the other one, they are pretty much the same thing, just calling a different contract with a different ABI on a different ledger. But this is about as different as it gets, and it will look almost exactly the same for the other ledgers as well. So the idea is that this should allow people to be more productive. And that's all I have. It's a very quick demo.
And what's cool is that you can do this like with Fabric and Besu as well. It's not necessarily it's a bunch of different like of the Hyperledger project. So it's not necessarily just Besu. Go Quorum, Cactus is cool because it kind of works with a bunch of different ledgers.
That's right.
Yeah. I'm just trying to get more people to build on Cactus. Yeah.
Thank you.
So does it out. What questions does everyone have? Wow, making it very easy on us. Well, I know.
I'm good. I'm done.
Yeah, no questions. You were perfect. All right, so the next demo we'll have is Besu with Lucas. So floor is yours.
Thank you very much. Let me set up the sharing here thing properly. I'll just share my whole screen, and I hope everyone can. So I think I'll share my whole desktop. Can everyone see my screen?
Yes.
Yes. Cool. Great. So I'll just bring another. This one is probably too small, but doesn't really matter too much. I'm just going to talk a little bit about what we're going to be doing here and a little bit about the topology of this network. So I want to show everyone 3 things today. I want to show how you can use Besu to connect to a mainnet network, which is probably going to be like a 5-second demo. So I'm going to save it to the end. I also want to show everyone how you can start your own private network. So I'm saying private network, but you can think about it as a consortium network. It's up to you who you want to connect to your network. It only depends on your rules for the network and things like that. And the other thing that I want to demonstrate is how you can use some of the enterprise features in Besu, like provisioning and private transactions. So we're going to go through it a little bit as well. One quick comment, because I think it was Mark who had a question about private transactions in a public network. So that's a really interesting question, because we do have, so the way that the privacy model that we implemented in Besu supports a public network, because I'll try to explain it without getting too much into the internals of how private transactions work. But basically, every time that two participants are, let's say that they're sending a private transaction between themselves, or 2 nodes in the network, we have a secondary network layer with Orion, which is like we call the private transaction manager, which is going to be responsible for transmitting the actual transaction payload between only the participants. And on the public side of the network, we create what we call a private transaction marker, which is a public transaction that contains a hash that can be used to retrieve the private payload from Orion. So, and for every node, when they see the public transaction and then they see that hash doesn't really mean anything. So all nodes that are not participants in the network, they'll just skip that transaction. It's just gonna, they're gonna treat it as a transaction that is storing some data in the chain or something like that. But for all Besu nodes that are a participant on that network, they will understand that that transaction is something else. And then they're going to use that key to retrieve the payload from Orion and execute that private transaction on their private state. So in Besu, we have this model where we have separate public and private states. So the public state is still, conforming to all the protocol rules, and the state root hashes match with all the other nodes. So you're seeing consensus with the network on the public side, but you have the option of doing your private transactions affecting your private state on the side, kind of thing. And another interesting concept is that we allow you from reading public data from private transactions. So you can even have a private transaction that reads some data from the public chain and uses that for some calculation or something. Of course, the other way around doesn't work. You can have like a public transaction that reads from private, because otherwise there's no point in calling it private anymore. So I hope this just quickly demonstrate how you could use this in a public network environment. I think we might have had a webinar in the past where we showed the public transaction. I'll see if I can dig it, and if I find it, I'll send you the link. But yeah, if you have any more questions about this specific public and private transactions You can find us on Rocket Chat, and then we can talk a bit, some of the internal details about it. So yeah, and just quickly talking about this topology here, we have 3 Besu nodes running. So you can see 1, 2, and 3 here. I know that the logs are a bit small, but probably doesn't matter too much at the moment. And on the side here, I have 3 Orion nodes running, each one connected to my Besu node. So basically 3 Besu nodes and 3 Orion nodes. And I also have 1 web application running here, which is the web application that we use to manage permissioning rules in Besu. So that's kind of a cool thing. It makes it really flashy for a demo because our permissioning rules, we have different modes, but one of the more robust modes is the mode where all the rules are saved in smart contracts. So you actually have a list of the inode URL that you expect to be able to connect to your network, and also a list of the accounts that you expect to be able to send transactions in this network. And the cool thing is that because they are stored in a smart contract, the management of those rules are really easy because everyone that joins the network will synchronize with the chain and then have the rules up to date. So that we have another mode where you can use like a configuration file to specify things, but it only works for, it works kind of like a firewall or something because the rules are not really shared between all the nodes. So of course, depending on the use case, one makes more sense over the other, but for like a consortium network, especially if you have entities outside your own organization, the on-chain option is probably a good fit because everything is synchronized on the chain. And again, I usually talk too fast, so if I'm going too fast or if anyone has any questions, yeah, just jump in because I want to make sure that everyone understands what's happening here. So 3 nodes. I'll start with the permissioning demo. So I'll bring up the DApp here. It looks kind of nice. Hopefully this one is big enough that anyone can see. So this is a DApp connected to my node, and then it is displaying the rules that we have in the permissioning smart contract. We're gonna have all the links for like docs and how to set up this yourself later on. But yeah, this is just so this one's not, you guys won't be able to follow yourselves now, but I'm gonna send all the links later so you can set up everything. And here we have basically 3 pages. One with the accounts that we are expecting that are able to send transactions in the network. It doesn't mean that the other's accounts won't be able to send a transaction. They can try, but then all the nodes are gonna check the sender of the transaction against the rules, and then they're going to reject the transaction because it's a invalid transaction from the permissioning point of view. The same thing for the nodes. You can see that I have 3 rules here. And of course, we have 3 nodes allowed to connect because that's the network that I have at the moment. If Grace decides to start up a node and try to connect to my network, unfortunately, all my nodes are going to be mean to her and say, no, you're not going to connect. And they're just going to reject her incoming requests. And the admins is a concept where you can have special accounts that you promote to admins, and those accounts are the accounts that are able to change the rules pretty much. So I can, delete rules and create rules here. You can see through this DApp. And in this case, I only have 1 account. That is the one that I'm connected at MetaMask at the moment. This is Besu account 1. Okay, so let me bring this one to the side. I think I'll start with the node permissioning just because it's probably one of the easiest one to do. I will go to the nodes page and I will remove one of the rules. So I think the zoom is making it a bit, okay, this one, hopefully it's not too small. Is it too small or is it okay to see?
It's okay. It's a little small, but
okay.
It's yeah.
Okay.
I'm looking at what's the first 2 numbers are 261. So 261 is going away.
Yeah. So basically each one of these entries correspond to one of the nodes here. So what I'm going to do first, I'm going to delete one of the nodes from this list, basically saying that this node is not allowed to transact in the network. It's unable to be removed. Let me refresh the page because it's been running for a while here. And let me make sure that I don't have anything from my previous run through, make sure that everything was working before. And I'll try again. Okay, cool. So as you can see here, because I'm running a consortium network, it's going to say that my fees are 0 because there's no point in using gas for this demo here. But again, you could be using this on a public network. it's only permissioning in a public network. It's interesting because you can't really enforce that every other node will be running Besu with permissioning enabled. So it is, I don't want to use the word complicated, but it's an interesting use case if you're trying to use permissioning in a public network. In a private network, sorry, Grace?
No, and just so one thing I think that you said was really worth saying again is, it's pretty, just with a click of a button, you can remove, so a node. It's that simple, and
Yeah.
it's and there's no gas. So permission networks, you can decide if you want to have gas within a permission network. Sometimes consortiums think it's valuable, sometimes they don't. But within a permission network, you can choose. Within public Ethereum, you don't get to decide. That's that.
Correct.
So.
Okay, so what happened here is that I removed that rule, and then using MetaMask, I've created a transaction to that contract. And you can see here from the logs that the third node here was the one that ended up being kicked out of the network. So you can see that it is giving this message where it's saying that it's waiting for peers and that it doesn't have a connection. And the other two nodes, they are still talking to each other. So this one is producing blocks, this one is importing blocks. And we basically kicked someone off the network using the rules. And again, this is like a 3-node network, so it wouldn't be that hard to just go, into 2 configuration files and updating some kind of rule, or maybe going, into 2 firewalls and removing those rules and creating those rules. But imagine that you had like 200, 500, 1,000 nodes. So keeping everything in sync and on all the rules the same without a ledger taking care of it, it can be hard. So just for fun, I'll try to do the opposite now. I'll try to add that node back just to create another rule here. And again, I'm using this DApp, but in reality, you don't really need the DApp. It's easy to automate that with some kind of script. One use case that I've seen that was really good is that you could have some kind of Oracle application querying the rules, the contract rules, and updating, for example, your AWS firewall rules based on the state of this contract. So I've seen this kind of interesting enterprise application where you have the contract, but you also want to have some kind of network layer security. So you can have some kind of, application that's going to be querying this smart contract for the up-to-date rules and make sure that your firewall rules are going to reflect the contract rules. So that's kind of an interesting use case. And again, after a while, all the nodes picked up the rules. So node 3 was trying to talk to node 1 and 2, but they were just rejecting it. At the moment that we updated the rules, node 1 and 2 pretty much opened the gate and said, yep, node 3, we're going to start talking to you again. And then node 3 is catching up with the network. Again, hopefully you guys can see that it's doing things again. Okay, let me move now to, I think I'll go to the private transaction one just because it's, where is it? There you go. Oh, sorry, I'm jumping between screens here. So private transactions. I just want to show you how we could, again, in a setup with 3 nodes, send private transactions between them. This is really a really simple example. We have the storage contract, and I don't know if everyone's familiar with Solidity, but this is a smart contract in which we can store a number, and then we have a function to store the number and a function to retrieve the number. Of course, that's probably not a super enterprise use case, but it's going to be good enough to show us what we will be doing here. And then in my examples, I'll show you how we can. So I'm not sure, again, if this is too deep into the code, but hopefully everyone will be able to follow up. But what we are doing here, forget about the setup code here. So I'll create a transaction that is going to be deploying this contract. And the interesting thing here is this private from and private for fields, which are not regular Ethereum fields. What this is saying is that I want to send this transaction from participant 1 to participant 1 and 2. So I'm saying that this transaction should be visible or available for these 2 participants, right? So node 1 and 2 are going to be able to see that transaction. And down the track here, I'm creating another transaction where node 2, so private from participant 2, is going to be updating the contract with some value. I think it's 5. I think it's hard coded to 5 at the moment. So just demonstrating that it's like it goes both ways. So I can create a, deploy a contract that is private between 2 parties or even more parties, and only the members of that party will be able to not only see the contract but interact with the contract. That's what I'm trying to demonstrate here. And hopefully, if the code wasn't clear, oops. If the code wasn't clear, my nice logs will be clear. Okay, cool. Let's see what's happening here. So we sent the transaction, and we can see that on the first node, we can see the receipt for the private transaction with a successful state. So that means that my node has successfully processed the private transaction. We can see the same thing with my second node. And the interesting thing is when the third node tries to get the receipt for that transaction, it is getting like a null response. The reason is it doesn't know about that transaction, right? Node 3 was never a member of that transaction, so it doesn't know about it. So, even if someone sends this hash to node 3 or something, it won't have access to it. So it doesn't know that there's something there. And we can see here the second node, that's the receipt for the transaction that updated the value. And this is the address of the private contract that we've deployed. Again, it lives on the private state. I'll copy this address because what I want to show you now is that we can read that value. And hopefully I've tapped this right. So I'm calling another script that is going to call the contract on that address and see what value is saved there. Okay, cool. Again, Besu1, that's the contract address and the value that is retrieving from the address. And the format is a bit weird because that's like the way that we are decoding things. I didn't do like a nice print, but you can see that it's saying the value 5 here. And hopefully you can see that Besu2 is also getting the value 5. And node 3, even though node 3 knew about this address somehow, so somehow it found out that there was an address on that, there was a contract on that address, it doesn't have access to it because it doesn't exist on its private state. So it's retrieving an empty value here. That's the way that Ethereum deals with if you try to call something that doesn't exist, basically. So even if node 3 tries to go through every possible contract address and tries to find data, it's never going to find it because the data doesn't exist on the node 3 on the node 3 database. It doesn't exist. So and I could try going through the logs here to show how this is happening, but I think it's going to be probably not that interesting. But you can see on the Orion logs, which is that intermediate, that auxiliarily, oh gosh, I can't say that word, that underlying network that makes sure of transmitting the encrypted data. You can see that we're going to have a few methods like push, where it's sending the data to the participants encrypted. And you're going to see this one calling a receive. So that's when the node is processing private transaction. It's trying to retrieve that private transaction. And you can see that node 3 pretty much only has this party info, which is almost like they keep alive in the network. They keep talking to each other to make sure that they're all online. But nothing happened on the Orion side here. And I think that's kind of what I have for a demo here. I'll stop sharing, but if anyone wants me to go back and show something, I can probably go back and talk a bit more. Oh, I forgot about showing, sorry, public Ethereum. That's,
yeah, I was getting all excited.
Oh, yeah. sorry. Let me go back here. That's the 5-second
feeling
one.
gypped. No, that is really cool because I love to see, I always, whenever you do this demo, I'm always like, it is crazy. You actually see like the send, the receive, the nodes stopping, talking to each other, I mean, I don't know, like I'm always, it's one of my favorite demos. So.
Yeah. And I keep promising that I'm going to try to implement like a proper DApp that uses privacy for something interesting, but I keep postponing it. So hopefully seeing the logs and the requests is not too boring for everyone else. For permissioning, we have the DApp and it's kind of cool. So I think I need ideas for building like a proper private one that makes it more interesting. So if anyone has an idea, please send it in the chat and maybe next time I can implement it. Okay, so running
or
Besu
contribute it, yeah.
That's also
shameless
possible.
plug. Yeah, show public Ethereum.
Okay, so for running Besu on mainnet, it's really easy actually. you need to download Besu and have it available for you. We're gonna have the links how to do it. But by default, Besu starts on mainnet. So there's nothing much that you need to configure. Basically, you need to say that you're gonna run Besu. You need to give it a data path because, I mean, you can use the default one. That's gonna be the folder that you are in. But in this case, I'm gonna give it like a temp Besu main, or maybe just Besu, I don't know. And the other one is that you need is this net method. And this one is only needed because I'm running it on my local computer inside my private network, right? I'm on my Wi-Fi. So this is something that we added in Besu recently that allows you to, automatically use UPnP to open the rules and the ports and everything that you need. Of course, if you're running this on AWS or some kind of like, server that is exposed to the world, you don't need to use UPnP. That's just because I'm running on my local network. But that makes it really easy for people that just want to get like a feeling of running a mainnet node locally. You can use this, so you don't have to worry about messing with your router and creating rules or static IPs or whatever. You don't have to worry about it. It's going to take care of everything. So if you do this, hopefully it won't take too long for us to see a few peers. Of course, we're not going to sit here and watch until it finds all the peers and everything. Oh, of course, sorry. I didn't stop my other nodes, so it's trying to get the same port and everyone else. Okay, because I'm using the same.
I was gonna say I don't know that much, but I see errors. Yeah.
Yeah. It's just because by default, Besu uses port 30303 for all the P2P connections, and then come on, it's just taking a while to shut down everything. And then because I was running the other nodes, I was running one on port 30303, the other one port 40404, and the other one 50505. So it's just complaining that it can't use the same port. So did it stop? So these are done. I'll probably stop my Orion nodes as well.
Yeah, that's a good idea.
Come on.
Any questions or comments?
Oh yeah, if anyone has a question while I sort out my
I know we only have 5 minutes left. We'll end and we'll do a 30-second end, so we'll let Lucas have all of the rest of the time. It looks like Greg, you have a question.
So we're looking at some kind of client, the Besu client, trying to connect to the Ethereum mainnet. Is that what we're looking at? Yeah,
that's the final part of the demo. Yeah.
So if I want to send gas, how do I go about it?
If that one, say that again, sorry.
I want to send gas. Isn't the gas like Ethereum's main currency?
Mm-hmm.
How do I go about it?
Oh, so if you want to make you mean if you want to make a transfer between accounts or something like that?
Yeah, I want to send gas to another address through Besu.
Sorry. I think I said something that was wrong. The currency is actually called Ether, not gas. I think that's what that's why I was confused. So the unit of like the currency in Ethereum is Ether. So what you're asking is how you could send Ether to someone else, like another account or something. Is that your question?
Ether gas unit of account.
Yeah, so it's probably
if they want to send it to another address through
Besu.
Okay, can I do that?
So you totally can. So you can use. So one of the things that it's probably gonna make your life easier. It's using a wallet application to keep track of your account and your keys and things like that. So you probably saw that I was using Metamask here. So Metamask. I'm not sharing my screen anymore, am I? Sorry. Let me share the whole screen again. So for example, here, I'm using MetaMask with some accounts, right? And you can see that they've got like some fake Ether here. I'm not a millionaire. I don't have that much Ether for real. But if you are connected to mainnet, you could use MetaMask to send a transaction through your Besu node, right? So the node itself is not responsible for managing your accounts and your keys. The node is it's almost like the plugin so you can connect to the network. If you want to transfer, Ether, or if you want to deploy a contract or anything that's going to create a transaction to interact with the network, you probably need a application that's going to deploy the contract or some kind of wallet to make it easier. So for example, here, if I connect to mainnet, you see that all my accounts now have 0 Ether, unfortunately. But you can use it, you can use things like this, to transfer like 10 Ether or something. And you can see that like 10 Ether will be $18,000. Nice. If I could transfer that, I would send it to everyone, but unfortunately I don't have it.
So I cannot send until I have a balance, basically.
Correct. Yeah, correct. And the reason that I have balance on my accounts on my fake network, just because I started the network with accounts that were rich, pretty much. So I could, so I had enough to demonstrate stuff. But on a real, on mainnet, you create an account and then you probably need to fund your account if you want to use it for some kind of transaction or something like that. I hope that answers your question. And I'll just run the demo here, but feel free to follow up if you have any more questions.
I'm good, thank you.
Cool. So we can see here, again, setting up the data path just because I want a specific folder to save this data, and the UPnP because I'm behind my router. But instantly, a lot of things coming up on screen, but we are already trying to talk to 4 peers here. So they are all peers from mainnet. We're going to keep talking to them. Some of them might not want to talk to us because we are new to the network, and they're actually interested in getting blocks from us instead of giving us blocks. So it might take a while until we actually find a good enough group of peers and start synchronizing with the chain. But that's why I said it was a 5-second demo. I just wanted to show you guys that by default, Besu is a mainnet client. So all the permissioning and privacy options that I was showing everyone they are all optional. You don't have to use them. You can just join mainnet, join some of the public test networks to get started with Ethereum and get your hands dirty.
Well, that's a good, I think, way to wrap up. I know we only have 2 minutes. We'll stay on an extra couple minutes if there are any other questions. We hope you really enjoyed this. We would love you to check out each of the projects that we shared, Cactus and Besu. I'll drop a couple links in the chat. We have one final poll. So if you thought this was interesting, we want that feedback. We want to know what you're interested in learning about.
Sorry, I forgot to stop sharing.
Oh, no worries.
You can see that Besu is already downloading blocks and stuff. So it's kind of cool. I'll stop sharing now.
Really cool. No, it's so cool. And I think, yeah, we want the Hyperledger community to be more familiar with Ethereum and comfortable with it and understand how it fits into the Hyperledger and enterprise blockchain ecosystem. So, always just looking for, any feedback y'all have. We're all on Rocket Chat, so feel free to message us on Rocket Chat and go from there. And looking at this last, it looks like use cases are the winner for our next section. So look out. We'll be getting that scheduled in the next month or two. And I want to thank Peter and Lucas for demoing and leading the charge. Much appreciated, guys. And we'll see y'all soon. But yeah, any other final questions, feel free to speak up.
Hey, Grace, is this limited to just Quorum or any of the Ethereum consensus stack?
So are you asking if we'll talk about different consensus products at a next session?
Well, I didn't know if it was just limited to Hyperledger, but I think I just answered my own question, so never mind.
Yeah, no worries. Yeah, no. So we'll probably the next session we'll talk about Besu and Cactus use cases and different networks that are running both of them. But Consensus we have our own kind of webinar series that talks about all of our different products and offerings and all that. But this audience will definitely be Hyperledger focused. But highly encourage, there's tons of great resources through Consensus as well as Hyperledger. So if you're looking to learn more, you're definitely in the right place.
Thank you.
Great.
I'm actually a mainstay on both the Hyperledger and the Consensus. So.
Oh, perfect. Good. Okay. Yes. That's exactly what I like to hear. Great. Well,
we want to stay agnostic, so we got to learn everything.
Okay. Well, I guess I'll allow that. No. Thanks all. We appreciate it. I think we can wrap up now. As I said, email, Rocket Chat, we're all available. Really appreciate it.